Hi, good evening. The question I picked for my homework is 15.8. Just for time purposes, I actually wrote down all the questions already. There's no work done if you want to pause the video. Now, this sheet behind me, this is the references I will be referring to from the entire chapter of 15.1. So I'm gonna break this video down in three parts. Part A through C, because they all chain, these questions chain together. These are all what I found, and then just some algebraic manipulations on the side here. Part D to E, then F and H, I and J, all the same. There is no work done. It is just strictly algebraic manipulation all here, and I will be referencing from this. Now, for the first question, before we start, there's also references from the pages and the equations I all pulled from before I start. To start off this problem, we're trying to look for the speed of waves on the string. Now, we're going to use the wave speed formula from the reference sheet that I mentioned. It's wave speed equals wavelength times frequency, but we got to find the wavelength. Now, referencing from 15.3, I believe, the relationship between two nodes is wavelength over 2. So we're already given the distance between two nodes, so I'm going to use simple algebra. I'm going to do the wavelength, and let me turn my camera for this. Wavelength equals 2 times 0.125. 0.125. We now have our wavelength. We're going to plug that back into our wave speed formula, and I'll be right back. So I wrote a few notes down. This is the frequency. This is the distance between two nodes, a over 2. That's a wave speed formula. This is just really basic. So my wave speed is 54 meters over seconds. This second question here is, what is the maximum transverse velocity at an antinode? We're just going to use angular frequency. From the reference sheet, I pulled out angular frequency equals 2 pi frequency. Really simple math here. Now, the reason why I'm finding angular frequency is because I need to find the maximum transverse acceleration. This is my math for that question, and I will be back for